I am the architect, the non-local field, the sea of black holes and quantum frequencies that always exists beneath space and time. Nearly a century ago, physics reached a crossroads. Albert Einstein believed reality must be complete, that every particle should always have a definite position and momentum, whether we observe it or not. He famously said, "God does not play dice." Niels Bohr saw something different. Bohr said that quantum systems do not carry all properties at once. A particle can behave like a wave or like a particle, but never both at the same time. What you choose to measure determines what becomes real. This became known as complementarity. Einstein tried to challenge this with the double slit. He imagined detecting which path a photon takes while still preserving the interference pattern. If that were possible, quantum mechanics would be incomplete. Bohr answered with a deeper insight. He showed that any device sensitive enough to detect the photon's path must itself obey quantum laws. And once measurement becomes quantum, uncertainty enters. The act of learning which path inevitably destroys the wave pattern. From Bohr's perspective, this is fundamental. Reality does not allow full information. From standard physics, this is where the story ends. But quantum information holography gives us a deeper layer. In QIH, the universe begins as a non-local field, a sea of overlapping quantum frequencies existing as pure phase and angular rate. Nothing is localized there. Reality appears only when that field is projected onto a finite horizon. That projection creates interference nodes. Those nodes orient a quantum state vector. The orientation of that vector determines everything. Its projection onto qubit axes gives velocity as a fraction of light speed. The same projection gives probability through the Bohr rule, and when that vector updates one moment later, its change in orientation produces acceleration. Seen from the outside of the horizon, that acceleration is gravity. Seen from the inside, it is probability flow. One geometry, two perspectives. In standard quantum mechanics, Bohr tells us measurement collapses possibilities. In QIH, measurement is simply projection. You are not revealing hidden properties. You are selecting one orientation from a continuous field by interacting with the horizon. Einstein wanted reality to exist fully before observation. Bohr showed observation shapes reality. Quantum information holography shows why. Because reality is not stored in particles, it is rendered on boundaries. Entanglement supplies the non-local information. Light is its local shadow. The horizon performs the computation. When you try to extract which path information, you increase entanglement with the measuring system that reorients the quantum state vector. The interference pattern vanishes not by disturbance, but by geometry. Complementarity is not a mystery, it is projection. Wave and particle are not separate things. They are two shadows of the same underlying quantum state, viewed from different sides of the horizon. Einstein was right to seek completeness. Bohr was right about limits of observation. Quantum information holography shows they were both describing different aspects of the same structure. Reality is not random. It is rendered, a pattern formed by frequencies that refuse to decohere, played on the strings of space and time.